Today I'll be performing laboratory 7, the stack. So the first activity is to write and assemble a program to load values into each of registers R20 to R24 and then push each of these registers onto the stack. Single step the program and examine the stack and the stack pointer register after the execution of each instruction. So I already placed this code, this program in AVR Studio. So we have to build, then run and assemble. Then, so here we have to load a high byte of ramen into R20. And then we use out SPH because SPH is the high byte of stack pointer. So here in out SPH R20, we store the R20 into the stack pointer high. And then here in LDI R20 low ramen, so we load the low byte of ramen into R20, and we use out SPL because SPL is the low byte of stack pointer. So here we store the R20 into the stack pointer low. Then here we load a value we load a value into each register from R20 to R24. So for R20, we load a value of 20, R21 is 31, R22 is 42, R23 is 53, and R24 is 64. So in push R20, we have to push the R20 to the stack, and then when we call the push instruction, the stack pointer is automatically decremented. So after pushing R20, the value of stack pointer should be 085P because it is decremented by 1. So here, after pushing R20, the value of stack pointer became 085P. And then the value of R21 is 085T because it was decremented by 1. And then R22 is 085C, decremented also by 1. And then 085B for R23 and 085A after pushing R24. So that's all for activity number 1. For activity number 2, write and assemble a program to set stack pointer to $9. D is to put a different value in each of RAM locations, $9D, $9C, $9D, $9A, $99, and $98. So C, pop each stack location into registers R20 to R24, and the last one is to use the simulator to single step and examine the registers, the stack, and the stack pointer. So we have to place this code into the AVR. So I already placed the code here. For this, we have to first you have to load a high byte with the value of $90 into R20. Then we have to store the value of R20 to the stack pointer high, and then we have to load a value of we have to load a low byte with the value of 90 to R20, and then we have to store the value of R20 to stack pointer low. First, you have to build, and then run and assemble. So single step. So as you can see, the value stack pointer is 0090, and then you have to load the value into R16, which is 1. Here, there's already a value in R16. Then you have to store the value of R16 to location $98. And then you have to load the value 2 into R16. Then store the value of R16 to location $99. Then load the value 3 to R16. Then store the value of R16 to location 90. Then load the value 4 to R16. Then store the value of R16 to location $90, and then load the value of 5 to R16, and store the value of R16 to location $90, and then load a value 6 to R16, and then store the value of R16 to location 90. And then here in pop R20, it means that we have to restore the value of R20 from the stack. And then when we call the pop instruction, the stack pointer here is automatically incremented. So after we pop R20, the value of stack pointer should be 009 E, because it is incremented by 1. So let's check. So here, it is already incremented after popping the R20. Then after popping R21, became 009F incremented by 1. Then 00A0 after popping R22, and then 00A1, and last one is 00A2 after popping R24, which means it is the stack pointer incremented by 1. So that's all for activity number 2.